Hey everyone, welcome back to the channel. Today, we're diving deep into sentiment analysis, one of the most powerful and practical applications of natural language processing. We'll explore everything from simple lexicon-based methods to cutting-edge transformer models. Whether you're analyzing customer reviews, monitoring social media, or building AI products, this video has you covered. And stick around till the end, because I'll show you exactly when to use each approach. Let's get started. So, what exactly is sentiment analysis? Sentiment analysis is the computational task of identifying and extracting subjective information from text. In simpler terms, it's teaching computers to understand emotions in text. The goal is to determine whether a piece of text expresses positive, neutral, or negative sentiment. For example, this product is amazing. That's clearly positive, right? The product arrived today. Neutral, just stating a fact. Worst purchase ever. Definitely negative. Now, why does this matter? Well, businesses process millions of customer reviews, tweets, and feedback daily. Manually reading all of them? Impossible. That's where sentiment analysis comes in. Let's start with the simplest approach, lexicon-based methods. Lexicon-based approaches use predefined dictionaries of words with sentiment scores. Think of it like a giant lookup table where each word has a positive or negative score. Here's how it works. You input text, the algorithm looks up each word in its dictionary, calculates a total score based on those words, and boom, you get your sentiment. The two most popular lexicon-based tools are VADER and TextBlob. Let's look at each. VADER is specifically designed for social media text. It's brilliant because it understands emojis, slang, capitalization, and even punctuation marks. Let me show you a quick example. Here's how simple VADER is to use. First, we import the VADER Sentiment Analyzer. Then, we create some example text. Notice I've included emojis here. VADER gives us 4 scores: negative, neutral, positive, and a compound score. The compound score is the most useful one. It ranges from -1, most negative, to +1, most positive. In this example, our positive text with the heart emoji gets a compound score of 0.89, which is highly positive. Now, TextBlob takes a slightly different approach. It provides 2 metrics, polarity and subjectivity. Polarity ranges from -1 to 1, showing how negative or positive the text is. Subjectivity ranges from 0 to 1, telling us whether the text is objective or subjective. The code is even simpler. Just create a TextBlob object and call the sentiment method. Easy peasy. So, when should you use lexicon-based methods? Let's talk pros and cons. The strengths are pretty compelling. They're lightning fast, we're talking milliseconds. No training data required, just install and use. Super easy to implement. As you saw, just a few lines of code. Interpretable. You can see exactly why it made a decision. Works well for straightforward cases. But there are limitations. No context understanding. It just looks at individual words. Struggles with sarcasm. This is a big one. Can't adapt to specific domains without manual work. Can't learn from data. It's static. Limited vocabulary. It only knows words in its dictionary. Here's a classic failure case. This movie is not bad at all. A lexicon sees not and bad and might score it negatively, even though the actual meaning is positive. This is where things get really interesting. Neural network approaches learn sentiment from data and understand context, making them much more powerful for complex text. Unlike lexicon methods that just look up words, neural networks learn patterns and relationships. They understand that not bad actually means something good. We'll cover 2 main neural approaches, LSTMs and transformers. Let's start with LSTMs. LSTMs are a type of recurrent neural network designed to remember long-term dependencies in sequential data. Think of it like reading a book. You don't just understand each word in isolation, you remember what came before to understand what comes next. That's exactly what LSTMs do. Here's how they work. 1. They process text word by word in sequence. They maintain a memory cell to store important context. They use special gates, forget gate, input gate, output gate, to control what information to keep or discard. This lets them capture dependencies between distant words in a sentence. So it's like word 1 goes into an LSTM cell, which passes information to the next cell processing word 2, and so on, until finally we get our sentiment production. Now, if LSTMs are good, transformers are game changers. They've revolutionized NLP. The main innovation is the self-attention mechanism. Instead of processing words one by one like LSTMs, transformers look at the entire sentence at once and figure out which words are important to each other. This gives us massive advantages. Bidirectional context, they understand words from both left and right simultaneously. Parallel processing makes training way faster. Pre-trained models, you can use models trained on billions of words. State-of-the-art results, they dominate all the benchmarks. You've probably heard of BERT, BERT, or Roberta. These are all transformer-based models, and they're incredibly powerful. Let me show you how to build a simple LSTM model for sentiment analysis using TensorFlow. First, we tokenize our text and convert it to sequences. Then we build the model. An embedding layer converts words to dense vectors, 2 LSTM layers with dropout for regularization, a final dense layer with sigmoid activation for binary classification. This is a simplified example. In production, you'd train this on thousands of labeled examples. Now, check out how easy it is to use a pre-trained transformer model. With the Hugging Face Transformers library, we can load a pre-trained model in just 3 lines. Here, we're using BERT, which has been fine-tuned specifically for sentiment analysis. Then we create a pipeline. This is like a magic wrapper that handles all the pre-processing and just pass in our text. That's it. The output gives us the sentiment label and a confidence score. In this example, the model is 99.98% confident that our text is positive. That's impressive. So let's compare the strengths and limitations of neural approaches. The strengths are substantial. Understands context and nuance. This is huge. Handles sarcasm much better than lexicon methods. Learns from data, gets better with more examples. State-of-the-art accuracy, 90 to 95% on benchmarks. Domain adaptable, you can fine-tune for your specific use case. Handles complex sentences with multiple clauses. But there are trade-offs. Requires training data, you need labeled examples. Computationally expensive, needs serious hardware. Slower inference, takes longer to process text. Less interpretable, it's a black box, hard to explain decisions. Needs GPUs for training, especially transformers. Can overfit on small beta sets. Just to put it in perspective, transformers typically hit 90 to 95% accuracy, LSTMs get 80 to 85%, and lexicon-based methods are around 70 to 80%. Now let's talk about the real world. Where is sentiment analysis actually used in business? Product feedback analysis. Companies like Amazon analyze millions of product reviews. Sentiment analysis helps them monitor customer satisfaction in real time, identify product issues quickly, track trends, and prioritize which features to improve. Social media monitoring. Brands use sentiment analysis for reputation management, crisis detection, tracking campaign effectiveness, and competitor analysis. Imagine catching a PR crisis before it explodes. That's the power here. Customer support teams use it to prioritize urgent tickets, route messages to appropriate teams, measure agent performance, and identify training needs. An angry customer gets immediate attention. Market research. Instead of manually reading thousands of survey responses, companies use sentiment analysis to understand customer preferences, track market trends, and gather competitive intelligence. Let me give you a concrete example. Imagine you're Amazon and you get 10,000 new product reviews every single day. Look at this comparison. For simple reviews like great value for money, both VADER and BERT do fine. But here's where it gets interesting. This is great if you enjoy wasting money with a sarcastic emoji. VADER sees the word great and rates it as positive with 65% confidence. Wrong. But BERT, with its context understanding, correctly identifies this as negative with 94% confidence. That's the difference between basic and advanced approaches. Okay, so you might be thinking, which one should I use for my project? Let me break it down for you. Use lexicon-based, VADER or text blob, when you need quick results right now. You have limited resources, no GPUs, small budget. You don't have training data. You're doing simple text analysis. Interpretability is crucial. You need to explain decisions. Examples: quick social media monitoring, initial feedback analysis, proof of concepts. Use LSTMs when sequential context matters for your data. You have a moderate data set, thousands of examples. You need custom domain training, but have budget constraints. You need some context understanding without transformer costs. Examples: email classification, moderate scale review analysis. Use transformers when you need the highest accuracy possible. You're dealing with complex text, sarcasm, nuance, irony. You have a large data set or can use pre-trained models. GPU resources are available. The stakes are high, business-critical decisions. Examples: enterprise analytics, brand monitoring, critical decision-making systems. Here's a simple flow chart to help you decide. First question: do you have training data? If no, go with lexicon-based methods. If yes, ask yourself, do I need the absolute best accuracy? Budget conscious? Then LSTMs are your friend. Need maximum accuracy? Go with transformers. Pro tip from personal experience: start with lexicon-based for your MVP. Get something working quickly, validate your idea, then upgrade to transformers as your needs and budget grow. Don't over-engineer from day one. And that's a wrap. We've covered everything from simple dictionary lookups to state-of-the-art transformers. Remember the key takeaways: lexicon-based, fast and simple. LSTMs, balanced performance. Transformers, state-of-the-art accuracy. Choose based on your specific needs, not what's coolest. If you found this helpful, smash that like button and subscribe for more AI and machine learning content. Drop a comment below telling me which method you're planning to use for your project. Have questions about sentiment analysis? Want me to dive deeper into transformers or show you how to fine-tune BERT? Let me know. Thanks for watching, and I'll see you in the next one. Happy coding!